Okay, so here we will solve another problem of bending stress. Here a cast iron bracket subjected to bending that has cross section like I form, like these dimensions are given here, you can see, with unequal flanges. In I section these are called flanges. This portion and this portion are called flanges, and the middle section, that is called web. Okay, so in this I section these two flanges are non-symmetrical. The dimensions of the sections are shown in figure. Now find the position of the neutral axis. So we have to find out the neutral axis, okay, and moment of inertia of the section about neutral axis. So we have to find out I. If the maximum bending moment on the section, M max is 40 meganewton millimeter, then determine the maximum bending stress. We have to find out this, okay, and what is the nature of this stress. Okay, that is our problem. So dimensions are given. If the dimensions are given, then we can find out the centroidal axis, and that centroidal axis will give us the neutral axis. Okay, we know the formula to find out the centroid. So we all know that the formula of finding out centroid is like this: a1y1 plus a2y2 plus a3y3 divided by a1 plus a2 plus a3. And if you look at it, this cross section is symmetrical about y-axis. So we do not need to find out the x bar, because the centroid will remain on the y-axis. So, and as well as x bar is not required, we need only y bar, and that y bar, if can be counted from the most bottom layer, that is from here, we will find out the distance of the centroid, that is y bar, from the bottom. And for that we will consider this section as 1, this section as 2, and this section as 3. Okay, now if we work on the formula, we need a1, a2, a3 and y1, y2, y3. So a1, let us find out, a1 is equal to area of the bottom flange. So 130 into 50, 130 into 50, okay, is equal to 6500 mm square, and y1 is equal to, for symmetry it will be 50 by 2, so that will be 25 mm. A2 will be equal to, look here, 200 into 50. So 200 into 50 will be equal to 10,000 mm square, and y2 will be here, so that means 100 plus 50. So 50 plus 200 by 2, that will be 150 mm. A3 will be equal to 200 into 50. Sorry, A2 was not 200 into 50. Yeah, A2 is also 200 into 50. 200 long and 50 is depth. Here 200 is width into 50 its depth. So it will again will be 10,000 mm square, and y3 will be equal to 50 plus 200 plus 50 by 2, and that means it will be 275 mm. Okay, so by putting all those values in here, we will get y bar will be equal to 166.51 mm. So from bottom flange, the neutral axis if this is the neutral axis, then it will be 166.51 mm. Okay. Now it has been given that the maximum bending moment 40 meganewton mm. So also we need to find out the moment of inertia about the neutral axis. Okay, now we know where the neutral axis is, that is 166.51 mm from the bottom. Okay, so now I is equal to the total moment of inertia of the section is I1 plus I2 plus I3, where I1, I2, I3 are the moment of inertia of the three different areas about the neutral axis. So I1 means moment of inertia of area A1 about neutral axis, and that will be equal to moment of inertia of bottom flange about an axis passing through its CG, plus we need to shift this moment of inertia to the neutral axis. So A1 into distance of its CG from neutral axis. Okay, so moment of inertia will be BD cube by 12. We know that B is 130 into D is 50 and BD cube by 12 plus A1 is, we have already found out, 6500 into this distance will be, we have found out 166.51 minus 50 by 2, and we have a square also. This is also square, and we have found out this formula from the first year where we have found out the moment of inertia. We have learned to find out the moment of inertia. Okay, solving this we'll get 131718 mm to the power 4. Please take care of the units. And similarly, this I2 is equal to 50 into 200 cube by 12 plus A2 into A2 value is 10,000. We just directly we can put it here. 10,000 into 166.51 minus 50 plus 200 by 2. I hope you can understand. $50 is this much, and the half of this A2 at a distance of 100 from this point. So here it will be 100, here it will be 50, and that will give us 150. Okay, now we will get the value 33605913.43 mm to the power 4. Similarly, I3 will be equal to 200 into 50 cube by 12 plus 10,000 into Y3 was at 275. So 275 minus neutral axis is 166.51. That is the distance square, and it will give us 284907234.9 millimeter 4. So the total I will be, we have got a mistake here. This value is wrong. This value will be 119784.134.3 mm to the power 4. So by calculating I1, I2 and I3 and putting it here, we will get 28490.723.4.9 mm to the power 4. So we have found out the I, or moment of inertia, of this whole section about its neutral axis, and we have also found out the neutral axis. Okay, so say this is neutral axis. So from the bottom to this point will be 166.51. Okay. Now the distance of CG from the upper top fiber is equal to 300 minus 166.51, which will give us 133.49 mm. So in this diagram, from neutral axis to the top point, having distance how much? Having distance 133.49. So this much is 133.49 mm. So this is 133.49, this is 166.51. So this is larger. So most stress will be on the bottom fiber because this distance is higher. So maximum stress will be here. Now we know that M by I equal to sigma by Y. So for Y max we will get sigma max. Now we need to find out this maximum bending stress. So for case of sigma max, we will use M by I into Y. Here must be that Y max. So M is given is 40 meganewton. So 40 meganewton mm. So 40 into 10 to the power 6 Newton mm divided by I, we have found out 284907234.9 millimeter to the power 4 into this Y max is 166.51, and as a result you will get 23.377, and it was a cantilever and load was like this, so it will bend like this. So for that, this bottom layer will produce, bottom layer will have max bending stress, and it will be so compression at the bottom and elongation on the top, so it will be compressive stress. Okay, so we have got our answer. So this is how we have to solve the different problems. You have to practice more and more from the solved examples from different books or from the internet, but you have to do it and as less as possible.